Hello and welcome to this video on solving the fixing to swapped nodes of a BST problem. Problem statement is, two of the nodes of a binary search tree are swapped, and we have to fix it without changing its structure. First, let's take a look at the correct BST function. This function takes in one parameter, the pointer to its root node. Now, we define two vectors, v and elements. V is used to store the in-order traversal of the BST, while elements will be used to store the two elements that are not in the correct order. The approach is to perform an in-order traversal of the BST and store the values in the vector v. Since the in-order traversals are sorted, but in this case, two elements will not be in the correct order. So, we will find the two elements that are not in the correct order, and then update the BST using pre-order traversal. Let's take a look at the in-order function signature. It takes two parameters. Root is a pointer to the root of the BST, and vector v is a reference to a vector that will store the values of the BST. The function first checks if the root node is null. If it is, it simply returns and does nothing. If the root node is not null, the function recursively calls in order on the left child of the root node to traverse and store the values of the left subtree in the vector. The function then pushes the value of the root node onto the vector v. Finally, the function recursively calls in order on the right child of the root node to traverse and store the values of the right subtree in the vector. Then find elements function is used to identify the two nodes in BST that have been swapped. Let's take a look at the find elements function signature. It takes two parameters, a vector v which contains the values of the nodes of the BST in ascending order, and an integer n which is the number of nodes in the BST. The function starts from the end of the vector v and checks for a pair of values v of I and v of I minus 1, such that v of I is less than v of I minus 1. This indicates that the two nodes corresponding to these values have been swapped. If such a pair is found, the function identifies the correct positions of the swapped nodes in the vector v by searching for the first value less than v of I to the left of I. It does this by decrementing the index j until it finds such a value, where v of j is less than v of I. Once the correct positions of the swapped nodes are identified, the function returns them. Now, swap1 and swap2 are Boolean variables used to keep track of whether the two nodes that have been swapped in the BST have been fixed. Initially, both variables are set to false because the BST has not been fixed yet. Now, we update the BST using pre-order traversal. Let's take a look at the pre-order function signature. It takes four parameters, root, a pointer to the root node of the BST, elements, which is a reference to the vector that contains the two swapped elements, bool swap1 and bool swap2 are references to the Boolean variables that keep track of whether the swapped nodes have been fixed. The function first checks if the root node is null. If it is, it simply returns and does nothing. If the swap1 variable is false and the value of the root node is equal to elements of 0, it means that the first swapped node has been found. In this case, the root node's value is set to elements of 1 and swap1 is set to true. Otherwise, the function checks if swap2 is false and if the value of the root node is equal to elements of 1. If this is true, it means that the second swapped node has been found. In this case, the root node's value is set to elements of 0, and swap2 is set to true. The function then recursively calls itself on the root node's left and right subtrees, passing in the same elements, swap1, and swap2 variables. Finally, we return the root pointer. And that's it. With this code, we are able to efficiently fix the BST by swapping the swapped nodes back. I hope this tutorial was helpful, and if you have any questions, feel free to ask in the comments. Thank you for watching.